All you CAD designers out there, we've got something for you. It's a short 1-hour course called Resilient CAD Modeling, or RCM, and teaches you a defined set of rules and best practices for creating robust CAD models that don't break. Spend more time designing your product instead of fixing a broken feature tree. Learn more by going to learnrcm.com. That's learnrcm.com.
Hi, everyone. We've set up this Being an Engineer podcast as an industry knowledge repository, if you will. We hope it'll be a tool where engineers can learn about and connect with other companies, technologies, people, resources, and opportunities. So make some connections and enjoy the show.
It's interesting in engineering, right? You always have to make these trade-offs. It's never just this one thing is slightly worse. That means we shouldn't do that. No, it's actually, we have to look at the whole picture, the whole experience from a customer's perspective. What's going to give them a better experience?
Hello and welcome to the Being an Engineer podcast. Today we're speaking with Ashutosh Shukla, who holds a degree in mechanical engineering and has worked for esteemed brands such as Bose, Apple, Snap, makers of Snapchat, and Facebook, now Meta. Over the years, Ash has served in the roles of mechanical design engineer, mechanical engineering manager, product design engineer, and currently serves as director of mechanical engineering at Rivian. Ash, welcome and thank you so much for joining us today on the show.
Thank you, Aaron, for having me. I'm really excited to be here and looking forward to a wonderful conversation on engineering.
Awesome. All right, let's nerd out. So, first question, what made you decide to become an engineer?
I think I have the cliche answer, unfortunately, for you. I had an aptitude for taking things apart when I was a kid. And when I put them back together, they used to work.
Nice.
So certainly had the knack. Love to get my hands on things. I loved airplanes and fast cars and just sort of, pretty much super typical cliche answer there. But so I, growing up through or getting through high school and found I did well in the maths and the sciences, continued to have an interest, and just continued to explore that space. Ended up at Georgia Tech, and one thing led to another, and still in engineering 20 years later.
Cool. Awesome. So, fast planes and cars. Tell me, have you driven any particularly fun cars, like an exotic sports car or anything like that?
I've driven a bunch of them. I actually just sold my exotic car a couple of days ago. I am.
What was it?
I had a Porsche 911, but
wow.
I caught the electric bug not too long ago. And interestingly enough, now I'm working in electric vehicle development, but I had a chance to drive one for a few days, and it just really changed my mind about the performance. And so I'm a convert. But over the years, I've had a chance to drive a bunch of different Porsches and McLarens and others. They're fun. They're absolutely fun.
I'm jealous. I've driven a few, but only very, very briefly around a track for, a few laps, something like that.
Well, that's honestly the best way to get to enjoy them. So,
right. It's not like you can do a whole lot, cruising down the main street, right, in your hometown.
That's right. Yeah. No, keep it on the track, and that's a place to enjoy it.
Yeah. Okay, well, you've worked for some very prestigious brands. I mean, Apple, Facebook, now Rivian. Has pursuing these premium brand companies been an intentional effort on your part, or did it kind of just happen that way?
I think it maybe started as intentional, and then once you're in it, you tend to follow network effects and follow one company to another as you progress in your career. But I would say that what drew me to the companies that I've worked for generally has been exposure to the products. I've always been very hands-on, and being a consumer in the space, I just found their products to be interesting. When I starting off when I went to Bose from college, I was aware of Bose's products and felt that they were quite good and thought it would be an interesting challenge to work on them. And I actually stayed at Bose for probably the longest stint in my career, close to 10 years, including some of the co-op times. And when the iPhone came out, just as part of my normal benchmarking, wanting to understand how things work, I had bought one and torn it down. And I was really just blown away by the level of optimization and detail they had crammed into such a small package while still having it be very, cosmetically clean and beautiful. And right then I basically decided, you know what, I'd love to work on this team. And fast forward a couple of years, I actually ended up on that team. And over the years, I've kind of generally been drawn to companies that are creating products that I've enjoyed. And I felt like it would be a good way to have impact as well as be challenged.
Yeah. What advice can you give to any engineers out there who might be interested in working for a quote unquote premium brand company?
I think the things to do is to prepare, is to network. And by preparation, I mean read up on the company, read up on their competitors, try to take an active interest in the products and services that they're offering, so that when you get to the stage of conversation with them, you can demonstrate your true impact, your true passion or interest that you have in them. Not everybody necessarily needs to be, 100% over the top fan of everything that they're working on all the time. But it certainly doesn't hurt to, again, be able to demonstrate that interest. Take time to prepare, take time to do some research, not just on the company, but the space in general, the competitors, the challenges, and even the counter competitors, right? If you may be interested in a company that's making product A, and there may be another company that makes something very different from them, but just in the same marketplace. You should try to learn about those as well. It can help you understand why some of the decisions are made and what some of the challenges in that space would be. So that, again.
When you applied at Apple, did you tell them that you'd taken apart one of the iPhones, and did that help at all?
I did, and I believe it helped. I met Apple, or I was able to apply to Apple pretty much directly. They had a job listed saying iPhone product design, and so I just applied to that online. And as part of my cover letter, I said, "Hey, I've taken one of your phones apart. I think it's really interesting and challenging. Would love to kind of take it to the next level." And of course, included my resume and portfolio of products I had worked on previously, and showed where there are similarities, and basically tried to demonstrate that I was bringing something to the table. Yeah.
Do you think that working at some of these more prestigious companies, does it lead to any more or less stress in the working environment than working at, I don't want to discount companies out there that aren't Apple or Facebook, but a normal company?
I think, so I would say this, of the companies that I've worked at, the level of stress and what you can, I guess, colloquially call work-life balance is different amongst all of them. And it's also different between the different departments and different business units within each one. So I wouldn't say it's a monoculture that each company either is or isn't, a very tough environment to be in or a stressful environment versus another. And I guess to answer your key question here, which is it, does the prestige correlate with stress level? And I would say no. And what else? And the reason we may perceive, or people may perceive, some of these companies as having prestige is because they have exposure to them. There may be a company out there that makes just pipes, straight stainless steel pipes. I may not know the name of them, but everybody who buys stainless steel pipes as part of their normal workflow is going to know the names of the top stainless steel companies out there, or pipe companies out there, right? So prestige is, I would say, it's kind of a relative thing, relative to what you have exposure to. And I'm sure, some piping companies have a really stressful environment, and some of them are super chill. It's really, I would say there isn't a super strong correlation.
Yeah. Okay. That's interesting. You described your time at Meta as inventing the future at Facebook Reality Labs. I'd never even heard of Facebook Reality Labs. So immediately that caught my attention, and I thought, that's a cool sounding name. I need to hear a little bit more about what went on there. What is Facebook Reality Labs, and what future were you inventing there?
Sure. They've now rebranded as Reality Labs, just as Facebook has branded to Meta. But, Facebook's mission, or one of its primary missions, is to connect the world. And I would say they've made some good progress on that, because if you take a look at Facebook, Instagram, and WhatsApp, something like, and my numbers may be off here, but several billion people, right? More than half the world is connected via one of those three to each other. So they've done quite a good job of doing that by providing social networking or communication tools and a platform to allow people to communicate and connect. In wanting to expand on that, they're also taking a look at what sort of hardware can help connect people. So two products which are out in the public at the moment. So Facebook has a line of products called, or Meta has a line of products called Portal, which are essentially devices for video chat and communication that are standalone devices you can place in your home and carry with you. They also, if you recall, Facebook purchased Oculus. So Oculus Quest and the variety of devices coming from under the Oculus brand are made and developed, designed by Facebook engineering. And again, those are helping people connect and interact in a very different manner than was possible 10, 15 years ago. And they're quite good, I would say. It was actually doing a demo of Oculus was one of the things that convinced me to join Facebook, actually.
Okay.
And so I would say broadly what Facebook, or what Reality Labs is trying to do, is to develop new methods for connection and interaction, right? The way we interface with devices and the way that devices help us interface with each other. So they're working on, and this is all public, they're working on, artificial reality glasses, VR devices, connectivity devices, and they have not just products that are coming out, but they also have large research teams that are doing, early stage research, looking at the fundamentals, not just the end product. So I think the team is several hundred or maybe several thousand engineers across Reality Labs working on a variety of problems and challenges related to, again, how people interact with devices and how devices help us interact with each other. So that was part of the work that I was doing there.
Very cool. Sounds like a neat place to work. I always think of Facebook as having armies of software engineers, and I guess it makes sense, especially with Oculus, right? But some of the other maybe less visible pieces of hardware that they have to have a whole bunch of mechanical engineers as well.
Yeah, I would say several hundred maybe. Wow. And Facebook is actually quite public about some of what they're doing. I think if you just, go into your favorite search engine and search for Reality Labs products and white papers, you'll be able to find quite a bit of interesting work that they've done, that they've published, that they're planning to do. It's all quite exciting. Some of it's at the leading edge, some of it's at the bleeding edge, some of it's at, even first principles of engineering and physics. So it's quite interesting.
Amazing. Yeah. Going back to Apple for a second, you were a lead engineer on the iPhone product development. Can you share maybe a story about what aspects of the iPhone you worked on? What was one of the big challenges that your team had to overcome, and how did you make those breakthroughs?
Absolutely. So I was at Apple during a time just when we were developing iPhone 4. And then I left just when I think iPhone 7 was under development. So I had a chance to work on iPhone 4, 5, 6, 6S, and then some other products which came after I left. But what was really interesting about the way that team operates is that there was an opportunity to rotate between responsibilities for each project. They did a really good job of not siloing or pigeonholing you into what you were good at. As you went from working on one product, which generally took a year to 2 years, you would, as you got staffed onto the next project, you were given a different responsibility compared to what you worked on before. So it was challenging, it was interesting, and you had a chance to essentially learn and grow. It also, meant that every time you had a whole new set of problems which you didn't necessarily know how to solve. So it certainly made for some interesting times. Over the years, I got a chance to work on the displays, the housings, the cameras, the acoustics, the buttons, and then the product as a whole, the battery system. I got to do a lot of rotations through different responsibilities. But I can tell you maybe about one of the most interesting developments that I got to work on, and also am super proud of, is the development of using sapphire crystal for the cover in front of the camera. So if you have a modern smartphone today, if any of the higher end ones, chances are it has a sapphire crystal camera cover lens. And, previously, or a few generations ago, those used to be glass. And, one of the things that our team at Apple used to get pushed on, of course, by industrial design, was to make the phone more compact, more sleek, more thin. And, if you essentially take a cross section through a phone, you've got the front display, you have a rear camera, and you have a lens or a window in front of it. So anything that you can slim out would allow you to make a more compact product. And so one of the things that we identified was taking up space was the thickness of the glass that was in there. And when we started, so I was responsible for designing that particular piece for iPhone 5. And when we started from blue sky, blank slate, as we did every couple of years, several people kind of identified an opportunity there. Hey, can we use something that's stronger, thinner, and better? And so the idea of using sapphire crystal came up. Now, sapphire crystal tends to get used quite a bit in watches and other applications, or had been previously. But to my knowledge, it had not been used in this kind of application before. So we said, okay, let's go investigate it. Well, as it turns out, it has much better scratch properties. You could make it half as thick and still be strong enough to survive. Wow. And so we said, okay, yeah, let's go ahead and do this. And of course, as you get into the details, we realize several things. One is there wasn't enough supply in the world because, Apple makes a lot of iPhones.
Yeah.
So, I think they make hundreds of thousands or maybe even more than 1 million a day when they went at peak capacity. So not only did we have to design this new part and this new material, we also had to work with our partners to go design an entire supply chain and a method for manufacturing it at scale, at quality, at quantity. And again, as you keep peeling the onion, we found, okay, well, in order to make it at high volumes, we had to develop a new laser cutting process. So we developed a laser cutting process. We realized, okay, we need to find enough lasers. So it just kept going. But, ultimately we were able to develop it. And it allowed for, a phone that performs better. You get better pictures because you have the sapphire cover lens on it. And it's actually another kind of interesting point here. If you look at it on paper compared to glass, its optical properties are not as good, but yet it helps you take better pictures. And the answer is because there's a great trade-off. By having a thinner lens, you can have a thicker camera. And so by giving space to the camera optics, you're still getting an overall performance win.
Interesting.
And because phones tend to get dropped, they tend to get taken in and out of backpacks and purses and in pockets with change. And now chances are, if you use a plastic or a glass lens, a few months down the road, it's going to get scratched up. So over if you use a phone for 3 to 4 years, you would have had poor performance for 75% of that time that you no longer do. So it's interesting in engineering, right? You always have to make these trade-offs. It's never just this one thing is slightly worse. That means we shouldn't do that. No, it's actually, we have to look at the whole picture, the whole experience from a customer's perspective. What's going to give them a better experience?
That's a great example. Really good story. Thank you for sharing that one.
Yeah, really enjoyed my time working on that challenge.
What's something about working at Apple that something interesting, you can define what interesting means, that people who have never worked at Apple might not know?
I would say, and I'm sure the company has continued to grow since I left, but when I first joined, I was surprised to see how small the team I was on.
Oh, right? Really?
Yeah. So you would think that, or, somebody might think that there is just an army of people designing every little bit and everybody's just focused on this one small piece of the puzzle. But the reality, or at least on my team, was that we actually had, this elite team of elite team of great engineers, and each of them had a significant amount of ownership and responsibility. And so what you had was stakeholders and decision makers that were able to understand a larger piece of the puzzle rather than being overly narrowly focused. And what that allowed is for optimizations to happen across systems rather than just at a piece part level. So yeah, you'd be surprised. I think when I joined and we were working on iPhone 5, I think there were maybe 6 or 7 mechanical engineers designing the phone.
Wow.
Yeah,
that's shocking. I would have thought 50 or 100.
Right. And again, now over the years, each phone and each of their products have become more and more complex. So those teams have gotten larger, but they've scaled with the complexity of the product. And I would say also, in fairness, it wasn't that we weren't the only mechanical engineers. We were the only mechanical design engineers, right? We had many other mechanical engineers supporting our operations teams, manufacturing teams, quality teams, reliability, et cetera. But the design team was quite small. Each individual sub-team, each person had a significant scope and breadth of responsibility. Apple, if you work with any of the companies in the Bay Area or the California, Bay Area, the term DRI often comes up and gets used by Apple alumni and now many other tech company alumni, but it means directly responsible individual. So generally, anytime there was an issue or a problem or something to be designed and, somebody wanted to understand the status or, what's going on, you would ask for who's the DRI. You wouldn't say, oh, what team is working on this or what division. You'd say, who's the DRI? Because for each thing, there was a person and it was their responsibility to go address it.
Always have one person's neck to wring, right? Then,
accountability. I would say accountability and responsibility, right? because that's how, to use, sports metaphors or whatever, but like that's how balls don't get dropped, right?
Right.
Somebody's always carrying something forward,
Yeah.
rather than people pointing at each other. Oh, I thought you were doing it. Oh, I thought you were doing. Oh, we're
Right.
doing it as a team. No, none of that. It's like for each issue, there's a person,
Yeah.
one person. Yeah.
I've always wondered for these products that have successive generations, not just the iPhone, but other products as well. What is the well, maybe answer specific for the iPhone if you can, since that's what we're talking about here. But how far in advance does the team start developing the next generation? So maybe iPhone 6 is out. Does iPhone 7 development start when iPhone 6 is launched, or was it started a year before iPhone 6 was launched?
Yeah. So it varies on the component, but I'd say working backwards from, my team, or our team, which was the mechanical design team, we would spend about 24 months working on a phone that you
Okay.
could say was new. When every other year there generally has been an S model, which is a
Yeah.
speed bump. Those usually get about 12 to 14 months maybe of development. But when you end
Okay.
up with a phone that looks new or has a whole bunch of updates, that tends to be about 24 months of development work from a
Cool.
mechanical design and engineer and system level integration side. I think the other part of that question maybe is if you take a look at the components that go inside, right? Every there are always new camera modules coming out. There are
Mm,
always new silicon and new sensors, and some of those can take multiple years to develop. And so I'm not an expert in silicon, but sometimes those SoCs will take 4 or 5 years of planning to develop. So not everything is perfectly aligned. Sometimes things skip a beat and they intersect when they intersect. So a
sure.
lot of
Yeah.
teams working in parallel. Um, electronic hardware product development generally tends to take 2 years, just because of the number of build cycles involved. Speed bump products tend to take about a year. Um, Lightning products, where I was on one product in my career that was done in 8 months, and that was just something the company wanted to supercharge. So there are always exceptions, depending on the complexity or the simplicity of the product or how much you really want to get it done. You can do something, but there are trade-offs, right? You end up having to either take risks during development or you have to sacrifice performance and take a safe route so you don't end up having to lose a build cycle.
Yeah. Oh,
Yeah.
that's great. I've always wondered that. Thanks for answering.
Yeah.
Okay. Well, this,
Be wary of Kickstarters that say you're going to, oh,
oh,
we're going to
yeah.
ship this product in 3 months. I'm like, no, I don't think so.
Yeah, exactly. Well, let me take a short break here and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. We're speaking with Ash Shukla today. So I'm going to kind of move on from some of the specific companies at which you have worked and get into a few more general questions about engineering. And the first one is, what is one thing that you see mechanical engineers doing that they should stop? And conversely, one thing that you see mechanical engineers not doing that they should start?
Well, one of the things that they should stop is, I would say, blindly following processes.
Hmm.
We often, and I've been guilty of this so many times, we often, anytime we run into a problem or need to do an analysis, we'll simply say, okay, well, what's the process? Okay. And whatever company or team you happen to work in generally has a way of doing things. And we just follow that process. Sometimes there are trademark processes. Sometimes they just have local names or informal names. But I think it's really critical for mechanical engineers, all engineers, to always take a step take a moment to say, whenever you're faced with an analysis or a root cause identification challenge or a problem or a design ahead of you, take a step back and say, what is the most appropriate process to use here, right? Don't let the tool guide your work. Select the right tool, select the right process that is appropriate to what you're trying to do. And, it doesn't, sometimes you can be fine. And many times the processes are there because they tend to be the right ones. But again, don't fall into the trap of always selecting the default, because there are many different ways to do things. And there's always some ways are going to be better than others. And the challenges are going to be different every time in front of you.
Yeah, it's good to challenge that status quo every now and then. We had a similar experience at Pipeline just the other day. There's a project management tool that we've been using for years and years and years, and it seems like it's working fine, but I can't remember exactly how we even got into it, but someone said, is this the right tool for us to be using? And it brought up just some really wonderful questions that led to valuable discussions. So a lot of value in challenging the status quo every now and then.
Yeah. And you certainly don't have to turn things upside down every single time, but even taking a minute before you start using a tool or a process to just ask yourself, okay, is this the right approach? Or is there a better way? Can really help you make some breakthroughs, avoid mistakes, avoid risks, save time, save your own stress, which I say is probably the most critical thing. But always take a step back, keep your mind open. And I think the second part to your question was, what should people do that they don't necessarily do enough of? And maybe an easy answer here is to ask those questions. I found that the most successful engineers are the ones that ask tons and tons and tons of questions, ask for clarification, ask to understand. They ask their peers, they ask their mentors, they ask their leaders, they ask their suppliers. I've had a chance to go and visit hundreds of different suppliers for the variety of parts that I've designed or engineered or worked on. And whenever I'm at a factory or at a supplier, I'm asking them, what is this machine? What does this do? How do you control the quality of this? Where do you get your materials? And if you just, again, try to learn everything you can about everything, ask tons and tons of questions, be annoying, be a little bit annoying, be a little extra annoying, even if you're, especially as you're starting out early in your career, it will help you go really, really far. And it'll help you become a better engineer and avoid a lot of mistakes as well.
Yeah. So this next question, feel free to take this from a professional standpoint or from a personal standpoint, your choice. I just think it's a really interesting question that I've had a lot of fun asking people. What is the most scared you've ever been, and what did you take away from that experience?
It's a great question. I'll try to answer it in the professional realm, I would say. Some of the I've been afraid several times throughout my career. Most of the times it tends to be around when we're either trying to ramp up production or we're in the middle of a prototype build. So anytime when we're starting up mass production on a new product, it can be a pretty nerve-wracking time because you are bringing up a variety of different machines and equipment and different workflows all coming together. And there's generally a good bit of pressure to try to get things moving. And you're also generally running a little bit behind on a variety of different things, validation, et cetera. And you end up getting test results. And on the one hand, the assembly line's starting to crank things out. On the other hand, you're like, are we sure we're designing this correctly? Are we absolutely sure things are working? And so many of the times that I've been scared have been when you get those something didn't work in validation, while the assembly line's starting to crank things up. You're like, wait, do we need to stop the line? And it's scary because you end up having to find a way to be really objective, right? You don't want to hold the company back. You don't want to hold the product back, but you also want to do the right thing. And so you have to really just, trust yourself, trust your team, and make the decision about if you need to stop something, then you need to stop it. And it can be a scary proposition to walk into a room full of people with executives and whatnot and say, hey, we have a problem. We need to stop, or we need to slow down, and let the data speak. Right? Ultimately, we want to make a good product. We want to have our customers have a good experience. We want to maintain our brand quality and reputation. And so, yeah, the scariest thing is to be able to, or is to have to say no sometimes, or to have to say, let's stop. Let's just not keep moving forward, and go solve those problems.
I can relate to that. We delivered a piece of equipment last year, and there was a lot of pressure on us to deliver it by a certain date. And it was not quite ready to deliver, but there was so much pressure on it that we relented, and we said, okay. And we told the customer, it's not ready. And they said, just deliver it anyway. We need it here. And so we did. And it ended up being a horrible decision. Our engineers had to go to their facility and work on it there. And it ended up taking probably several weeks longer than it would have if we had just said, we really need to keep it here and finish, our validation process before we deliver it. So that was a big lesson to us, stand your ground and say no sometimes. Like you said, let the data speak for itself.
Correct. Yeah. And there have been many instances in the world when things have gotten really bad because of a failure of somebody being able to say, we should not do this, or them not being listened to, with catastrophic results. And so I think, as engineers, as people who are essentially being asked by society to be objective in what they're developing and designing and building, we can take that sense of ownership and responsibility and hold up the flag when it's time to say stop. And there may be repercussions, but you will sleep better. Ultimately, you will sleep better having made the right call.
Yep, agreed. Well, what's one thing that you get to do as director of mechanical engineering that you love and never got to do in a previous role? And then conversely, what's one responsibility that you have as director that maybe you don't love so much?
One of the things I really enjoy is the ability to help frame out and build our team. I've joined a team that, and this is a fairly young company, so not everything's fully, built out yet. So I have the ability to help drive or shape the structure of our team to, take inputs from everybody and identify what sort of subject matter experts that we need to bring on. What sort of expertise do we want to have within our team? Where do we want our engineers to learn and grow? And the ability to essentially shape that, you could say it's almost like a curriculum. I really, really enjoy that because it allows me to reflect back on the time when I was earlier in my career and think about all the things I wish somebody had put together in front of me and said, here's a structured path to growing. I get to now do that for the people on my team. So really looking forward to being able to do that, because in my previous roles, I was generally focused on product rather than team and organization. And so now I get to do that. I think the other part of your question, what don't I love? I would say generally roles that come with organizational challenges and responsibilities also tend to come with a lot of paperwork and administrative work and budgeting and planning. And some of it is fun. Some of it is maybe less fun. But that's, there the administrative tasks, I would say, are less fun for sure.
Yeah, sure. Comes with the territory.
Yeah.
Yeah. Um, have you come across maybe a tool that could be really helpful for mechanical engineers or even manufacturing engineers that just doesn't exist? What's some tool out there that should exist that doesn't?
Yeah, and I love this question, and I'll give an abstract answer. The answer is community. So if you take a look at our friends in the software development world, as a software developer, there are so many forums and websites and channels of communication where they talk to each other across companies, across countries, and they find solutions to common problems. They teach each other, they learn from each other continuously, right? You go to Stack Overflow, go to Google, go to Quora, go to, I don't know, hundreds of subreddits like about different types of software development problems. You can just go find a solution or talk to people. As a mechanical engineer, some of those communities exist, but I would say none of them are really, or I don't know of any that are at the level that they ought to be. Like if I don't know, if I'm designing a fixture and I need to bond some aluminum to, I don't know, some plastic part, right? What's the best glue to use? Now, I could do some Googling, I could maybe read through some brochures, but there's not necessarily a community of people that I can just access very easily and talk to and share these kinds of challenges with. And so I think, I would say things have gotten better recently as workplaces have moved to using real-time communications, right? People are using Slack and other IM type tools over emails and files and folders. And then you can have channels where maybe mechanical engineers from one team can easily talk to ones working in a different business unit, right? If you have a big company and people will pose questions, they talk about it. So I think it's starting to grow, maybe at a inter-company level, but I'm hoping that one day there will be a one that's, agnostic to what company you're at, so that, when you have generic questions, things that aren't trade secrets or sensitive, you're able to learn from each other. And there is one more kind of piece to that, which is that sense of community and how that ties back to our curriculums in our colleges and universities. Again, when you take a look at the software world, the curriculums in computer science over the last 20 years have rapidly changed. Every 2 to 4 years, they change which tools are being taught, how they're being taught. I mean, the principles are still the same, but the tool sets and the way that they're used and taught change because there's this influx of feedback and information coming from software developers back to the universities and colleges because it's an open conversation on the web and in person. I don't know that that's happening in the mechanical space or maybe, many of the more physical engineering domains. They're probably still teaching the same heat transfer problems, but, there probably have been enough developments that are worth maybe bringing back into the curriculum and sharing with students so that they have a better sense of relevancy of, okay, I'm learning this, whatever equation, but how does that actually apply to the type of product I'm developing? I think it's a gap, and we should try to address that.
What a wonderful answer. I would not have thought of community as an answer to that question, but culture is a big part of what I focus on at work. And I think culture and community tie in very closely. And the idea of having these forums, which, you mentioned that there are some out there that exist, but maybe not in a big or robust enough sense to provide the value that really could be provided should someone build a tool like that. So great answer. I love that.
Yeah, thank you. Oh, well, you're doing your part here, right? You're actually helping bridge.
We are.
You're bringing people together, and these conversations are I think fundamental to having that sense of community being built out. and
That is part of the
information,
mission of the podcast.
yeah,
Yeah, a
information
repository
flowing.
of. Yep, exactly. Yeah. What are your goals as an engineer, and have they changed over the years?
Yeah, absolutely. I would say my goals have changed over the years. Early on in my career, I was pretty focused on working on consumer products that I found to be interesting, right? I thought audio gear was pretty cool. I loved working on it. Smartphones had just started to really make their mark in the world, and I really enjoyed working on those as well. Early on, I also wanted to make sure that I was growing and learning. So a lot of my focus was on just asking questions, trying to understand, and being involved on developing products that essentially I would want to buy, and I thought were pretty cool. Over the years, I would say what has changed is that from a impact standpoint, I've moved from wanting to work on specific types of products to wanting to drive impact in a way that would be beneficial to the way we live and the way we treat our environment as a whole.
Yeah.
And that's certainly one of the driving factors behind why I made my most recent career change to work on electric vehicles, because I believe that fundamentally accelerating the development of electric vehicles will help reduce pollution, air pollution, and allow us to essentially live in a more sustainable environment. The other goal that's changed, essentially moving from being in a learning mode to being in a teaching mode, or being in an advisory mode. I feel like I'm going to continue to try to learn, of course, but I also believe that over 20 years, I've been able to build up a repository of knowledge, and hopefully I can share my perspective and help guide others and help others develop along their journeys as well. So, somewhat in a transition from student to teacher sort of mode, but you never really stop learning either.
Let's hope not. Yeah. Learning is what makes it fun, I think. As soon as I've found that over the years, as soon as I get really good at something, it stops being as interesting as it was. And I need to find something else that's really hard. And there's a lot of joy that comes from doing hard things, especially with people that you care about.
Absolutely. Yeah. I think it's one of the great joys in life is to work on something that's difficult and to have that moment where all of a sudden it clicks or it makes sense. And those are just wonderful moments. And once you get over that, you have to go find the next one.
Exactly. Yep.
And it's essentially, by working on things that are challenging, we are creating a foundation, or we're continuing to build on the foundation that society and the world is built on, right? We're building upon layers and layers of things that have been developed by generations that have come before us. And so we're just continuing to add to it by tackling challenging problems and building solutions.
Well, Ash, this has been really wonderful. I appreciate you so much for taking the time to speak with me today and share all of this terrific insight and wisdom that you've accumulated over the years. How can people get a hold of you?
The best way to get in touch with me would be just to reach out to me via LinkedIn. I think if you search for A.Y. Shukla, or Ashutosh Shukla, you should be able to find me pretty easily. Shoot me a note to connect, send a message, introduce yourself. I'd be happy to connect and offer any help that I can.
Terrific. Anything else that we should talk about that we haven't hit on yet?
No, I think I really enjoyed our conversation. It's been helped me reflect quite a bit as well, and hoping this reaches the ears of people who find it helpful and insightful. And thank you again for setting up this opportunity and for continuing to work on developing this platform and helping engineers and students and aspirees learn. Thank you.
Oh, you're so welcome. And thank you again for being on the Being an Engineer podcast.
Thanks, Aaron.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.